We now turn our attention to while loops. You understand for loops and the fact that they essentially cycle through lists of values in order to essentially perform iterations. While loops, however, differ. While loops essentially test at the top of the loop for an exit status of 0. So whatever you put in the top of your while loop or in the descriptor of your while loop as a test must equate to 0 in order for the loop to iterate. And once it's no longer equating to 0, or whatever iteration changes 0 to some other value as an exit status, then the while loop exits. Let's show you an example. We'll navigate to temp 2. We currently have a few for loops but no while loops. Let's touch a while loop. This will be called while loop 1.shell script. We'll modify it as we have done with everything else. We'll set up the headers, author information, date, etc. This is all boilerplate stuff. And we begin and end our loops. So in a while loop, for example, we can do some tests such as min to max, the lowest number to the max, and have the loop do iterations based on those numbers. Let's show you one example where you'll commonly find an implementation of the while loop. We'll set a number, for example, a minimum number, set it to 0. So we'll say num is equivalent to 0, and we'll be consistent. We'll make it uppercase. Num is equivalent to 0. Let's also set a max. Let's say we'd like to run our loop through X number of iterations from num to max or min to max. We'll set the max initially as 20. Now we can define a while loop which will operate between the borders of 0, which is a min, but we're calling the variable num, and 20, which is the max. So we can do that number of things in between 0 and 20 as the while loop will help us out. So let's define the while loop here. We'll say while, and the syntax is quite simple. Open brackets, while the variable you have in question, or whatever condition you want to test. It doesn't have to be the equation of, or testing of the equation, or matching of two numbers. You could also test other things, such as commands. So while num, and here's a test, is actually less than max. We could also do less than and equal to. We'll show you. While num is less than max, we'll do something. Let's close brackets. Now, just like with the for loop, no differently from the for loop, if you're going to include the do on the same line as the while, you need to terminate the while with a semicolon and then begin your do. But I suggest you just keep both values on separate lines. Now we'll tell the while loop to do something, and we can have it echo the current number. And of course, as you've imagined, we're going to increment the number by 1. Next line will be essentially to increment count, or the number, the base number, by 1. So we'll let num, and it's uppercase, plus or equal 1 to increment its value by 1 so we can get through the loop. And then we'll end it with a done. So the format is pretty much the same as a for loop, with the exception of the brackets, in that you specify the type of loop, while or for, or even until. You have a condition that we're testing, do, the body of the loop, done. It's as simple as that. So num currently is set to 0 at the beginning of the script. Num will be less than max all the way up to the number 19. When it gets to 20, num will no longer be less than max, num will be equivalent to max. And because we're testing currently using the less than, the last value that we expect to see printed should be the number 19. And then after we echo the number, we increment it by 1. Let's source this file. As you can see here, we have values including 0. Recall, 0 is a value, and num was initially set to 0, and the condition was true. The condition that we tested returned an exit status of 0. So the initial condition was is num, which was initially equivalent to 0, is num or was num less than max. Max was 20. And that returned an exit status of 0, so we echoed it. If you wanted to tailor this, you could change the number. Let's show you some variations on this while loop. Let's say, for example, we wanted to say less than or equal to. That's quite possible. Now we actually get the value 20, and we still have the value 0 as the beginning value. So we actually have more values. We have 21 values, including 0 and the number 20, just by changing the condition test from less than to actually less than or equal to. Now, how about if we try to do greater than? You'll see that this while loop is going to fail, and you should know why immediately. Recall, with a while loop, the condition testing takes place at the very top of the loop, right here. This condition, this descriptor, needs to equate to an exit status of 0. If it doesn't, the rest of the loop does not continue. That's important to understand. So when you're defining your scripts and you think about the logical conditions that you need, then you'll know what type of loop will help you out in a given situation or be appropriate for a situation. A while loop tests for an exit status of 0 at the very top of the loop, so it must equate to 0. So let's attempt to run what we're doing here. We're going to say while num, which is currently set to 0 or begins as 0, while num is greater than max 20. So while 0 is greater than 20, do this stuff. This should fail. Let's exit, and we'll source it again. Notice that we get no output this time. Now you may be wondering, what is the exit status of the script? Well, simply echo it. You see the exit status is 0 because the script actually did run, but the script's test of an exit status is independent of the exit status returned by the script as a whole. So the script ran successfully, but the while loop failed. So the while loop failed, but the script did run. None of the steps in the script failed. Let's modify that script again. Recall, the entire script ran, but the while loop controls the block of code in between it. The while loop is responsible for this section of the code. This section of the code did not run, but that does not mean that the entire script didn't run. The entire script did run. The script ran up to this point and stopped, so it was a successful script. As far as the shell is concerned, the contents of the while loop is subordinate to the while loop definition itself. So when it got here, num, which was set to 0 in the first iteration, or by default, was not greater than max. So 0 was not greater than 20. So the while loop didn't proceed with the rest of the loop. Now what if we were to set num to a higher value? Let's say we set num to 20. Would this work? So essentially we're testing, while 20 is greater than 20, do the following. This is also going to fail. Let's show you that. See, it's failed as well. And you can echo the output. It's still 0. Let's modify the while loop shell to show you why. 20 is not greater than 20. 20 is equal to 20. So it won't work. However, what if we made num 21? This will succeed because num is greater than 20. So as long as num is greater than 20, keep doing the loop. It begins at 21, so it's greater. It then becomes 22, but guess what? This is a runaway loop. This is the type of loop that can eventually exhaust your system resources, or if you are sending the output to a file, eventually if this script isn't terminated by force, either by Control-C or by closing the shell or by killing the process, it will eventually run away and either create a very large file, no different than running sequence for a long time, or just use your system resources. Let's show you how this one works. We'll source it again. Now look at this. It's already up to almost 5,000, 6,000. The thing is, the while loop will continue to run because it's true. This proves that it's actually checking for an exit status of true, or an exit status of 0. For the bash environment, an exit status of 0 is true, unlike Boolean where 0 is typically false, 1 is true. Well, 21 was higher than 20, so it continued to run. Now we can break this with a Control-C. Now imagine if we were to send this output to a file. Let's show you how quickly the file would grow. We'll send the output to while loop 1.txt. Now we won't see anything on the screen, but the file will continue to grow. If we're to execute a Control-Shift-T to open a new shell, navigate into temp2, we can look at the file growing. And we'll just do an LSL while loop.txt, and we'll just watch it. It's already up to 337K, 404K, and it'll just keep growing. Now, that's all within a matter of seconds. You figure if this keeps running for hours, we could easily have a file that is potentially gigabytes big. And if you left this running, let's say overnight or for a couple days, it could exhaust even a 100 or 200 gigabyte hard drive. So this is one way to certainly screw up a system. Just have a while loop continuously running, or an until loop in a reverse fashion. We'll be showing you the until loop next, which is the exact opposite of the while loop. It just does a reverse check. We're already over a meg with this thing. So what we need to do is kill this process. It's now killed, and we can modify the loop again to see what else we can do in here. So 21 is greater than 20, it ran. A while loop is another great way of executing a process very quickly, very repetitively. So you could, for example, set the parameters, the borders, let's say 0 through 20, and then do a test within here. So while num is less than or equal to, LE, less than or equal to, do something. Perhaps you're testing to see whether or not a particular service is running, or if a host is accessible. You could check to see if a service is running, or whatever you want. This is a great way to repeat the same block of code very, very fast. So it's good for testing. If you're concerned about a service being down, well, run an iteration 20 times to keep telnetting into the service. That's one way to do it. A while loop essentially tests for an exit status of 0. You can pretty much put any condition here. If you'd like, within the double quotes, you could do command substitution and run a command. The test would no longer be based on num and max. It would be based on the exit status of the command substitution's output. So if we ran something within here, it needs to return an exit status of 0 in order for the loop to proceed. And we could do anything within here. We could ping, we could check something, we could check a directory, parse a file, you name it. This is really all up to you, depending on what you want to test. Essentially, you need to understand the concept, the critical concept behind while loops. The critical concept is that all the testing gets done up top, and unlike a for loop that actually cycles through a list, a while loop checks for an exit status of 0 purposely. If it is 0, it does everything in the body as long as the status remains 0. So it does one iteration, it checks again, is it still 0? Second iteration, checks again, is it still 0? And as long as the test that's performed up top exits with a status of 0, as we showed you with a basic example comparing num to max, as long as it's 0, the body of the while loop will continue to execute. The second it's no longer 0, the while loop exits and the rest of the script can continue processing. In this case, there's really nothing else to do in a script but to exit. So that's the critical concept behind the while loop, and you'll see us use it throughout some of the scripts that we define. Now, as mentioned before, an until loop is the exact opposite of a while loop. A while loop tests at the top the condition to see whether or not the exit status is 0. An until loop essentially tests until the exit status is 0. It's a little confusing initially to understand. However, just think of them as being opposites, and think that when you typically use a while loop, you're testing for true conditions, and you want to loop when it's true. When you use an until condition, you want to loop while false. So you want to loop while false, and in a second it becomes true, stop. With a while loop, you want to loop while true, and then the second it becomes false, stop. So you can use both of them if you reverse your logic. Let's show some examples of the until loop. Have no examples here. We have the while loop. We'll create one. We'll call this one until loop 1.shell, and it has nothing. We can ignore the comments if you'd like, although it's good practice to include them. Essentially author date, etc. And the more you type it, the more you get into routine, the more it becomes part of your typical habits. A revision number doesn't help, etc. So with an until loop, we can do things like counting down, whereas with a while loop, we showed you an example of counting up from perhaps 0 to 20. How about if we counted down from like 100 to 20? Well, let's set two variables. We'll set one called num. Num is equivalent to 100, and we'll set a value called min. Min will be equivalent to 20. This is where we want to stop. So an until loop aids us with this quite easily. You could do the same with a while loop, you just need to switch the logic and it becomes confusing. So what we'll say here is as follows. The syntax is exact. It's until, open brackets, same format, until a condition, perhaps until condition is true. Do, and typically semicolon, do, command, done. This is essentially how it works. So our condition here is going to be as follows. Until num, which is currently 100, is equal to our new min value, which is 20, we're going to do something. And we can do whatever we want. Here we can just start off by echoing. It always helps to echo so that you see what's happening before putting actual code. But there's one other thing we need to do here. Unlike what we did with the while example where we incremented by 1, we need to decrement by 1. So we get to show you a little different technique using the until loop. So what we'll do is we'll decrement the value of num each iteration of the loop. And it works just like with incrementing. You use the let command. The let command is a reserved bash command which allows you to increment, decrement values within a script. So we'll let num be decremented by using minus. Instead of plus equal, we use minus equal 1. Now the let value allows you to increment or decrement by whatever steps you want. Not necessarily 1. It's just common to increment or decrement by 1. But you could specify otherwise. And then we need to end the loop here. So simple logic. Right now num is 100. We're counting down from 100 to 20. So until num, so until 100 is actually equivalent to 20, do some things. Now because we're echoing the num, don't expect num when it reaches the value of 20 to actually be echoed. Because remember, an until loop is opposite of a while loop. Once the value is actually equal and it returns a status of 0, it stops. And all the testing gets done up top. So if you wanted to actually echo the value of 20, we need to drop 20 to 19. And we'll show you what we mean after. Let's exit this and we'll source it. This is our first until loop. Here are the values. We can scroll up looking for them. All the way up to the first value, 100. So num was initially set to 100. And it counted down all the way until it hit 20 and it was equal. But the last echoed value, as you can see here, was 21. It should make perfect sense to you. Let's revisit the script to show you what we mean. And this helps in terms of more complex scripting where you don't understand why a particular value is not being outputted. In order to get the next value, we need to go down a level. Because remember, with an until loop, like with a while loop, the test occurs in the very first line of the loop. Nothing else happens. If the test checks out in the top of an until loop to match an exit status of 0, the rest of the loop or the remainder of the until loop doesn't occur. And vice versa for a while loop. Let's show you that in action again. So it'll actually equate to 19, but it won't be echoed because that's the stop point for the loop. Now we actually get the value 20 because we're testing for an equation to 19. Let's look at that again. And this could be any value. You can set this to 1,000, 10,000 if you'd like, and just watch it, let it rip. And if you'd like, you can send the output to a file. Here we're counting from 10,000 backwards to 20. We're test at 19, but we stop at 20. And as usual, this can be sent to a file. We'll send this to until loop.txt so we don't see the output. Excellent. It actually does its thing. Now we have a newly created file, until loop.txt, which we can actually run through using perhaps our page or less. And you'll see the values from 10,000 all the way down. Just keep pressing space and it should cycle through all of the values for you. But of course you don't want to do that. And if you'd like, you can count up the values in this particular file to see what's in there, how many values, etc. Well, we stop at 20, of course, so that explains the number of values. 9981, including 10,000, and the value 20, so it's an extra value. Also, another thing I want to show you, you can run scripts and suppress the output other than using regular redirection to a file that's created on the file system. You can send things to /dev/null. So if you want to suppress the output of this particular script or any script, send the value to dev null, and then you won't see it on the screen. Dev null is like a black hole. Anything you send there will not be created. So no output's dumped to the screen. Excellent. So an until loop works in reverse. We can do other things, such as scripts that check for ping. Like, for example, let's copy this until loop 1 shell to until loop 2 shell to show you like a systems administrative type use of this particular looping mechanism. We'll look at until loop 2. Now let's say, for example, we're not concerned about counting down numbers, but we're more concerned with system administrative type work, such as the status of pinging a given host. Well, we can actually ping a given host. We can check a status throughout the loop, and then once it becomes the value that we have an interest, then we can actually stop doing what we're doing. Let's show you what we mean. Let's kill all these lines, and we'll do an until, open brackets of course, following the syntax, until a variable status which is yet to be set. So until status is equivalent to 0. Remember, until loops stop when they get an exit status of 0. Until the status equivalent to 0, we're going to ping a particular host on the network, which doesn't exist, by the way, so we'll end up with an indefinite ping. We're going to ping, and we'll send, for each loop, for each iteration of the loop, we'll send one packet. We don't want to flood the network. And we're going to ping a host which actually doesn't exist on the network, .35, and we can show you that. We'll Control-Shift-T. We'll ping sending one packet over to 192.168.1.35, and as you can see, the host doesn't exist. And when we echo the exit status after having run the ping, it comes back with 1. So, ping this particular host, send one packet, and we can also echo it's down, or the host is down. Excellent. And then we finish the loop. So what will happen here is as follows. This loop will run indefinitely until a status of 0 is met, which will never happen. Now, of course, in a networked environment, let's say there's a particular host that's down. You may have more sophisticated tools for checking availability, but you could have a simple 10-line script or less like this, which just keeps ripping, and then the second the host is up, it exits the loop. And once it exits the loop, then you know that the system's back up. Or you could have a while loop do the reverse. But the until loop could certainly keep testing, this particular host. And if it's down, just keep echoing the host is down. You don't have to echo. You could change this echo or pipe this echo, as we've shown you before, to, let's say, mail, and send this out to a particular user. And it'll just keep flooding the mailbox until the given host is up. And you can also choose to run the shell script at different intervals. Let's exit. Let's show you how this works. So let's source until 2 loop, or until loop 2.shell. Now this will keep pinging, and it says integer expression expected because we initially set status, but status isn't there. It's a variable that wasn't defined up top. So this keeps occurring because the error level is 1. Until this host actually comes up, it'll just keep running and running and keep sending one packet out to the remote host. And of course, we could redirect the output of this file. You Control C many times to break it. We could redirect the output of the file to a log file for further analysis. And we could add additional information, not just echo the host is down. We could add the date, timestamp, you name it. So this host is down, and there's nothing much we can do about it. Now we can check with a valid host, such as .2 or .1. .1 is our default gateway, and we can try to source this particular script using an until loop until the host is down. So let's take a look at this. Until the status is 0, come back. Well, the status isn't 0. Excellent. So an until loop works out pretty well in that it can perform a reverse function of the while loop. So if you need a situation where you need to either count down or check until a condition is true, you want to check a false condition until it's true, use an until loop as the opposite of a while loop. Now what we should show you is one other thing. We need to set a status variable. Let's go right here, because upon each iteration we should set status to be equivalent to the output, the error level that is. So let's set it. So we're going to say here status is equivalent to, this needs to be equivalent to the command substitution of the output of the error level. So this should be set to the error level because this is what we're testing. So after each iteration, status is equivalent to echo $? What we showed you before ran indefinitely because status never changed. Excellent. Now let's exit the script and we'll source again. Now in this case it exits. It prints the host is down because we have it echoed there, but it actually is up because we finally hit the right error level. And recall, we didn't set status initially, so it says integer expression expected. We didn't set status initially, so we got an integer error. And because status was not set, the until loop actually ran, so it echoed the host was down. But then, of course, it set the status right after that to 0, and the loop didn't proceed thereafter. However, let's go back to the case of a bad host, such as 35, and when we rerun this particular script, no different. Now let's go back into here. This host 1.35 doesn't actually exist. Excellent, and the status comes back nicely.